History books taught us this. We landed on the moon in 1969, and it was only the first step in our journey to the stars. The next target was Mars. It was the logical choice. But we were wrong. So, terribly wrong. Because right after that victory, humanity hit the brakes. An unbelievable silence began. A silence that has now lasted for 50 years. Why haven't we returned to a place we reached in just 3 days for half a century? This should have seemed impossible, because a power that mobilized hundreds of thousands of people and a massive industry doesn't just stop at its peak. But the truly shocking part is that this project was never designed to have a next step. Which raises the question, was the story we were told completely wrong? If you too are wondering about the real reason we haven't returned to the moon in 50 years, then like this video and subscribe to the channel, because everything you think you know is about to be shattered. Are you ready? Let's begin. For years, we thought the moon landing was the beginning of a great age of exploration. We believed that humanity's first step on another world was the first second of an unstoppable march of progress, as if moon bases and journeys to Mars would begin the very next day. But that's not what happened. Everything suddenly went quiet. 50 years of silence. This wasn't because of a failure. It wasn't because we lost the technology. It was because we had misunderstood the real reason from the very beginning. We had overlooked the true purpose of the journey to the moon. Now we know that giant leap was not a beginning, but the harbinger of an end. To understand this, we must first change our perspective. That journey to the moon was not just a few astronauts climbing into a capsule. It was never just that. Think of it this way. Imagine rising from a room in your house to the city, from the city to the country, and from the country into orbit. That massive system you see, the factories, the ports, the schools, and the political systems, that is what going to the moon was. It was the simultaneous contraction of an entire national civilization's muscles for a single goal. This is why the moon is not as distant as it is in poems, because the moon is just far enough to expose a country's entire power structure. This is the first observation we must make. Humanity did not go to the moon as a natural extension of a scientific rhythm. On the contrary, it was pushed there, in an extremely special and high-pressure historical environment. But why? Why would a civilization focus all its power on such a single point? Because the real fuel of the moon project wasn't just liquid oxygen and kerosene. The project's real fuel was the competition of ideologies, strategic deterrence, and global prestige. This was less an exploration mission, and more a race that had to be won. It all began in 1957, when the Soviet Union launched the first artificial satellite. That signal was like an alarm bell ringing over the entire world. So, within a few years, humanity was catapulted from its ancient posture of gazing at the stars to an era where space became a political reality. As a result, President Kennedy set that famous goal in 1961, to land a man on the moon and bring him back safely before the decade was out. This political declaration defined the project's DNA. The goal was not the moon itself, but who would get there first. This is why NASA brought together thousands of people who were genuinely passionate about science. The engineers in the Flight Control Center, the navigation team at the Massachusetts Institute of Technology, and the genius of Wernher von Braun behind the Saturn V rocket. Most of them hoped that the moon landing would open a long-term era of exploration. However, the resources they used were not being steadily supplied by a nation of pure research, because those resources were temporarily concentrated within a highly pragmatic political machine. The moment the logic of the race changed, that machine would immediately rewrite its priorities. This brings us to the third and perhaps most important concept. The Apollo program was not a sustainable transportation system. Apollo was a historic race car. Imagine you want to go to work every day. But, for this, you built a race car with an incredible top speed, filled with sensitive instruments, maintained by 100 technicians, and requiring the entire route to be closed to traffic every time it runs. The first time you reach your destination, everyone is shocked. The second time, people are still amazed. But, the third time, the question becomes very practical. Is this really a sustainable form of transportation? Apollo was exactly that, a historic high-performance race car. It could win the race, but it was never suited to become a daily system because the Saturn V rocket, with its height of over 100 meters and immense launch power, was single-use. The command module, the service module, the lunar module, each part was essentially a massive consumable built for a single mission. This wasn't an airline route, it was a superlimit breakthrough forced by history. Such a system is great for delivering a decisive blow, but it is a complete fiasco when it comes to becoming a routine operation. This is why Apollo's greatest moment of triumph also nurtured the very conditions that prepared its own end. In short, we have three fundamental truths. First, going to the moon was a massive act, showcasing the industrial and political power of an entire nation. Second, the primary driving force of this act was not scientific curiosity, but a Cold War race that had to be won. And third, the system designed for this race was inherently unsustainable, incredibly expensive, and optimized for a one-time victory. When all these pieces come together, it becomes clear that the 50-year silence was not an anomaly. On the contrary, it was an inevitable outcome coded into the project from the very beginning. But how did these structural problems transform into a concrete break in the budget meetings in Washington and in the political bargains behind closed doors? How did victory itself become the switch that pulled the plug? Because the project's real vulnerability lay at the intersection of these three layers, and the thing that exposed this intersection was victory itself. And at the intersection of these three layers lay the project's true vulnerability: politics, finance, and technology. These three factors, once victory was achieved, brought all the previously suppressed contradictions to the surface at the same time. Because, after the victory, the moon itself was not powerful enough to persuade the system to continue at the same cost. This doesn't mean that political will suddenly vanished. On the contrary, it was the redirection of that will to other, more urgent, and more utilitarian goals. The first concrete sign of this redirection was the missions that were cancelled even during the project's brightest period. The Apollo program was actually planned for up to 20 missions. Apollo 18, 19, and 20. The hardware for these missions had been produced. Saturn V rockets were waiting in warehouses, but they never flew. Because in the political priority list, the moon had lost its place. The first footprint could shake the world, but a fourth sample collection mission could not make the voters hold their breath again. The value of politics often peaks at the first showing. This is why, immediately after the victory, the project's budget was subjected to a ruthless review. And this review brings us to a second and more concrete layer: the project's mind-boggling cost. Because Apollo was not just expensive, it was UN-sustainably expensive. The total cost of the program was approximately $280 billion in today's money. This included not just the rockets, but the salaries of hundreds of thousands of people, the contracts of tens of thousands of companies, countless test facilities, and a global tracking network. This massive expenditure could be achieved for a short time when the nation was in a state of mobilization. But it was impossible to repeat it for long, in a normal peacetime period. But the real problem was not the size of the cost. The problem was what this cost was competing with. The America of the late 1960s and early 1970s was not a tranquil society that could forever indulge in the euphoria of the moon's victory. The Vietnam War was consuming enormous resources. The pressure of domestic inflation was increasing. The civil rights movement, social divisions, urban problems, and welfare spending were all competing for national attention. While one side of the television screen showed astronauts bouncing on the moon, the other side showed war, protests, and political crises. The moon was magnificent, but it could not automatically answer the worries on Earth. Therefore, national budgets are decided not by emotion, but amidst concrete bills, domestic issues, diplomatic crises, and election battles. No matter how high, if a scientific value cannot be instantly converted into visible political returns, it quickly loses its priority. The moon fell right into this trap. This brings us to the third and most brutal layer: risk. Apollo was not just expensive, it was also an extremely high-risk form of spending. Every launch, every separation, every re-entry into the atmosphere Any failure meant a disaster broadcast live on national channels. The true face of this risk was seen even before the project began. With the Apollo 1 fire in 1967, Gus Grissom, Edward White, and Roger Chaffee died inside the capsule while still on the ground. This event was not a random accident relegated to the footnotes of technological history. It was a brutal slap in the face to the entire moon landing project, because sending people to the moon was not about gently pushing heroes into the sky. It was about launching them into a complex system with extremely low tolerance for error. Every step taken was earned in exchange for extremely expensive tests, redesigns, and countless sleepless nights. The public applauded success, but budget departments and political decision-makers always saw the shadow of failure as well. And after the victory was won, the question of whether it was worth taking this risk again and again began to be asked with increasing volume. It was these three layers, the shift in political priority, the unsustainable costs, and the unacceptable risks, that came together immediately after the victory to create the perfect storm that stopped the Apollo program. The moon hadn't moved further away, rocket technology hadn't vanished overnight, scientists hadn't suddenly lost their curiosity. What truly vanished was the political imperative that had rushed the entire system to the moon at any cost. When the urgency of "we have to win" diminished, the moon landing project had to face a brutal interrogation. Was it really worth spending so much money, so many resources, and taking such high political risks to go to a place that had already been visited? The answer to that question, under the conditions of that era, was unfortunately no. But this end did not mean the end of humanity's space adventure. On the contrary, it was just a change in strategy. So where were the resources redirected after being pulled from the moon? And how does this new direction show us more clearly what the moon lost to during that period? And the answer was far more mundane, yet just as ruthless as we might have imagined. The resources were not directed to a more distant planet or an interstellar mission, but quite the opposite, to a place much closer to Earth. Because while the moon was abandoned, space was never abandoned. Only the rules and the playing field of the game changed, and the discoveries made on this new field were at least as shocking as the moon landing. Only these discoveries were not made in the sky, but in budget tables and strategy documents. The first shocking discovery was this: low Earth orbit. It doesn't sound very romantic. It lacks the poetry of the moon. But this is precisely what dethroned the moon, because as the euphoria of Apollo's victory faded, decision-makers realized a much more practical truth. Space was not just a place to go and plant a flag. Space was an infrastructure, and the most valuable part of this infrastructure was just a few hundred kilometers up. Therefore, while the production lines for moon rockets were being shut down, another industry was growing silently and rapidly: communication satellites, spy satellites, weather satellites, GPS systems. None of these offered a single moment of heroism, but every day, every hour, every second, they provided a concrete, measurable, and institutional benefit. While a multi-billion-dollar Apollo mission gives you a single historic victory, a satellite network in low orbit provides you with years of intelligence, global communication, or economic advantage. This was space as a system, and a system is always stronger than a single event. SO. The moon suddenly became a target that was both too glorious and too useless. According to the logic of a system, this should not have happened. Humanity's greatest adventure should not have lost to a more boring but more profitable alternative. But it did, because corporate logic is always more patient than poetic dreams. But that wasn't the real shock, because the system never openly said it was giving up on the moon. On the contrary, it put a new and brighter promise in its place: the space shuttle. This was the second and more ruthless discovery. The shuttle came with the promise of reusability. It would routinize space, lower costs, and reopen the path to the moon and beyond. On paper, it was perfect. But, in reality, the program itself was a colossal illusion. The promised cost per launch was around $10 to $20 million. But, in reality, this figure climbed to over $500 million to $1 billion, depending on the mission. The promise was that it would be ready to fly again in weeks. But, in reality, it required months of complex and expensive maintenance after each flight. This was not a bus. It was an extremely complex prototype, that had to be almost rebuilt each time. SO, throughout its 135 flight history, the space shuttle never made space cheaper. On the contrary, it trapped the American civilian space program in low Earth orbit for decades, because it was so expensive and so complex that it left no resources for other major projects. This was something that should not have happened. A system designed to make space commonplace paradoxically made space even more exclusive and inaccessible. But that is exactly what happened, because the shuttle was not a pure engineering solution. It was a complex political compromise that united the interests of different aerospace and military lobbies, NASA and politicians. And this compromise sealed the moon's fate a second time. And now we come to the truly earth-shattering discovery. This was not a rocket nor a budget. It was the human mind itself. The decay of public interest. This was the most invisible but most powerful break. The Apollo 11 moon landing was the most watched event in human history. The whole world held its breath. But what happened in the subsequent missions? Apollo 12, 13, 14. With each new mission, television ratings dropped. Media interest waned. For people, going to the moon had transformed from a miracle to a news item and then to a commonplace event. This wasn't ingratitude. This was the working principle of the human brain. Our brain is extremely sensitive to firsts, but it quickly habituates to repeated successes. Therefore, public support, a vital indicator for the political life of a project, was slowly consumed by the victories themselves. This should not have happened. The excitement of humanity's greatest adventure should have lasted forever. But it didn't, because political support depends on public interest. And public interest always shifts to the next new thing, the next crisis, the next drama. The moon itself became a victim of its own success, because victory itself did not act as a fuel to keep interest alive, but as a poison that consumed interest over time. The practical utility of low orbit, the broken promise of the space shuttle, and the inevitable decay of public interest. These three ruthless discoveries paint the non-superficial picture of why we abandoned the moon. But when these three factors come together, they reveal a deeper, more fundamental question. All these decisions actually revolved around a single core truth: the deadly tension between victory and sustainability. So how did this tension become embedded in the DNA of modern states and institutions? And how does this shape not only Apollo's past, but also the future of today's return to the moon goals? Because without understanding this structural contradiction, we can never fully see why history tends to repeat itself, and why the new moon race risks being a copy of the old one. And at the heart of this contradiction lies that deadly tension between victory and sustainability. And this tension emerged at the most decisive moment of the Cold War, the Soviet Union's defeat in the moon race. But this was not a defeat as we know it. This was the fourth and most ironic discovery, because most people think the Soviets gave up because the US landed on the moon. But the truth is far more complex. The Soviets' own moon program was centered around the massive N1 rocket. This rocket was an answer to the Saturn V, but the N1 failed in all four of its test launches, and these failures were not ordinary. 1. The launch attempt in 1969 went down in history as one of the largest non-nuclear explosions ever. Therefore, the US victory did not deter the Soviets. What was already deterring them were their own internal technological and organizational problems. The US success simply became the perfect excuse for the Soviets to quietly shelve their own program. This should not have happened. It was illogical for a superpower to give up when its greatest rival achieved its greatest victory. On the contrary, it should have become even more ambitious. But the Soviet system preferred to silently accept defeat rather than publicly explain such a massive and costly failure. This situation eliminated the most fundamental dynamic that kept the Apollo project alive. The competitor was no longer chasing. SO for the US, which had become a racer running alone on the track. There was no point in continuing the race. But the final blow came not from space, but from Earth, the Nixon administration. This was the fifth and most political discovery, because when Richard Nixon became president, he found far more urgent problems on his desk than Apollo. The war in Vietnam, social unrest at home, and rising inflation. Therefore, for Nixon, the moon program was an expensive luxury, a legacy of Kennedy. It was not a tool for victory, but a budgetary burden. So, even while in office, he began to make ruthless cuts to NASA's budget. The grand plans for a manned space program after Apollo, such as a Mars mission in the 1980s, died before they were even born. This was something that should not have happened. A nation's greatest technological achievement should not have been so easily sacrificed by a change in political will. But it was, because political systems operate not on the memory of past victories, but on the calculation of future elections. For Nixon, every dollar spent on the moon was a dollar that could be spent on a more urgent problem on Earth. This pragmatism drove the final nail into Apollo's coffin. The moon program was not terminated because of a failure, but was liquidated immediately after its brightest success by the cold logic of political and economic reality. And so, humanity's greatest exploration project became the victim of a series of ruthless discoveries. The silent but profitable rise of low orbit, the deceptive promise of the space shuttle, the natural decay of public interest, the withdrawal of the competitor from the race, and finally, the cold reality of terrestrial politics. All of this explains why the moon landing was an end, not a beginning. Because Apollo was designed from the very beginning not as a scientific exploration program, but as a political victory project. And when victory was won, the project's reason for existence also vanished. Humanity did not abandon the moon. Only the special and temporary historical conditions that enabled it to go there disappeared. What was left behind was a question that remained unanswered for 50 years. If going to the moon was a political necessity back then, what does it mean to return to the moon today? Is this new race also about flags and firsts? Or is humanity, after a half-century hiatus, finally trying to find a way to go to the moon, not for victory, but to stay? Because the goals of this new era, concepts like water ice, bases, resource utilization, a stepping stone to Mars, are very different from the language of the Apollo era. So is this new language just a modern packaging of the old competition? Or is it truly the beginning of a new logic that holds the potential to transform humanity's presence in space from an event into a system? And what lessons have the technology, organization, and financial models behind this new logic learned from the fragile structure of Apollo? Because the answer to these questions will determine whether the next footprint will be a permanent one. And the first clues to that answer. The answer to these questions will determine whether the next footprint will be a permanent one. And the first clues to that answer lie not at the point where Apollo left off, but in the brand new technological and institutional approaches developed since then. So what exactly is behind this new logic? How does this new language work? It is now time to slow the tempo, to delve into a deeper and more technical domain. Because the most fundamental thing that separates today's return to the moon goals from Apollo is not just the answer to the why question, but also the solutions found for the how question. The first and most fundamental mechanism of this new approach is the philosophy of in situ resource utilization, or ISRU. This may sound like a technical term, but its logic is extremely simple. It's like planning a long journey. Instead of taking everything with you, you plan to use what you can find at your destination. The Apollo program had to carry everything the astronauts needed from Earth: water, oxygen, and fuel. This was a method that incredibly increased the rocket's launch weight and sent costs soaring. Because in space travel, every single kilogram costs thousands of dollars. ISRU changes this equation completely. It aims to turn the moon itself into a gas station and a water source. Because discoveries made in the last 2 decades have shown that billions of tons of water ice may exist, especially in the permanently shadowed craters in the moon's polar regions. This water is not just for astronauts to drink. Through electrolysis, it can be broken down into its components, hydrogen and oxygen. Oxygen is vital for breathing. Hydrogen and oxygen are one of the most powerful fuel combinations for rockets. Therefore, instead of carrying tens of thousands of kilograms of water and fuel from Earth, establishing just a few tons of a mining and processing facility on the moon changes the entire architecture. This is the first and most critical step in the transition from Apollo's go and return logic to a go and stay logic. Because This mechanism has the potential to transform the moon from a place merely visited into a refueling point, a logistics base for deeper space missions. But you need energy to extract and process these resources. This brings us to the second fundamental mechanism, the energy infrastructure on the moon. Apollo missions, being short-term, largely met their energy needs from batteries and fuel cells. These methods were sufficient for missions lasting a few days. But when you want to build a base and stay there for months or even years, you need a sustainable energy source. The moon's surface experiences days lasting about 14 Earth days and nights lasting 14 Earth days. This long and freezing night period is a major problem for solar panels. Therefore, new generation lunar missions are focusing on two main strategies to solve this problem. First, peaks of eternal light. These are places like high-altitude crater rims near the moon's poles. These points receive sunlight for about 80 to 90% of the year due to their orbital motion. So, solar panel farms established here can provide an almost uninterrupted energy supply. The second is nuclear fission reactors. Initiatives like NASA's Kilopower project are developing compact nuclear reactors designed for use in space, which are small, safe, and can produce continuous energy for up to 10 years. These reactors, about the size of a person, can be sent to the moon in a single launch and can produce around 10 kilowatts of electricity, enough to power several homes. This ensures the base's survival even during the long lunar nights, allowing scientific experiments to continue and resource processing plants to operate. Therefore, solving the energy problem removes one of the biggest technical obstacles to establishing a permanent presence on the moon. And to build this permanent presence, we need something else in addition to human power: robotic systems and autonomy. This is the third and perhaps most revolutionary mechanism. The Apollo program was entirely human-centric. Every step was controlled by highly trained astronauts and a massive support team on Earth. But this was both very risky and very expensive, because every manned mission requires complex life support systems, radiation shields, and emergency scenarios. Today's approach is based on the concept of pioneer robots. That is, long before humans go, autonomous robots go and prepare the infrastructure, just like how construction machines level the land, lay the foundation, and draw the main lines before building a house. These robots can identify the most suitable locations for bases. They can install solar panels and nuclear reactors. Using the lunar soil called regolith, they can build landing pads, roads, and even the outer shells of habitats for radiation protection. With 3D printers, this allows us to use humans more safely and efficiently. Instead of being construction workers, astronauts can focus directly on scientific research and complex operations. Therefore, robotics and autonomy not only reduce cost and risk, they also exponentially increase the scale and speed of what we can do on the moon. Because a robot can continue to work in the negative 170 degrees Celsius lunar night and during radiation storms. This transforms the age of human exploration into an age of human-robot collaboration. These three mechanisms, in situ resource utilization, sustainable energy infrastructure, and pioneer robotic systems, are the cornerstones of today's vision for returning to the moon. These are capabilities that Apollo did not have, could not even have imagined. But this technical revolution is not just about hardware. It also brings with it a whole new corporate and financial architecture, because it's no longer just governments in the game. This brings us to the fourth and most transformative mechanism, the commercial space ecosystem. So how are these new players changing the equation that governments have been unable to solve for decades? And can this commercial revolution permanently open the way to the moon, or is it just creating a new bubble? Because the answer to this question lies not only in technology, but also in the economic model that brings this technology to life. And at the heart of this model is the fourth and most transformative mechanism, the commercial space ecosystem. In the Apollo era, going to space was a job that only governments could do. NASA built a massive industrial network to design, build, and operate the rockets. But, in the end, everything depended on a single customer, the government. Today, the situation is very different. Companies like SpaceX, Blue Origin, and Rocket Lab are turning space travel into a service. This is like buying a ticket from an airline instead of building your own plane. NASA no longer has to do everything itself. It can purchase the different services needed to carry out a mission from different private companies, just like a shopping list. For example, for one mission, it can procure launch services from SpaceX, the lunar lander from Astrobotic, and a scientific instrument to be used on the surface from another specialized company. This model is called Space as a Service, and it is the exact opposite of Apollo's massive, cumbersome, and monolithic structure, because this structure encourages competition. It forces cost-reducing innovations like reusable rockets, and most importantly, it distributes the financial and operational burden on the government's shoulders. Therefore, on the next moon mission, we will see many different company logos alongside the NASA logo. This has the potential to make the path to the moon cheaper, faster, and more flexible. Because now, if a single rocket program fails, not all dreams are shattered. Another player in the ecosystem can fill that gap. This is a level of flexibility and resilience that Apollo did not have. But just reaching the moon is not enough. To be permanent there, you also need to communicate. This brings us to the fifth critical mechanism: Earth-Moon communication networks and navigation. During the Apollo missions, communicating with Earth was an incredibly complex and expensive operation. NASA had to use its Deep Space Network, DSN, a collection of giant antennas spread across the globe. Each mission occupied almost the entire capacity of this network by itself. This meant that only 1 or 2 missions could be supported at the same time. But if you imagine a future with dozens of robots on the lunar surface, a few manned bases, and orbiting stations, this model is completely inadequate. Therefore, the next generation lunar architecture aims to build its own lunar internet and lunar GPS. Just like on Earth, a series of communication and navigation satellites placed in lunar orbit will provide uninterrupted high-speed data transmission and precise location information to every point on the surface. This is the main goal of projects like LunarNet. This way, a robot on the far side of the moon can communicate with Earth instantly. An astronaut can see their own location and the location of nearby bases on a map on their helmet's display. This incredibly simplifies operations, increases safety, and reduces cost. Because now, each mission doesn't need to set up its own complex communication system. Everyone can benefit from this common infrastructure service. This transforms the moon from a distant place to be explored into a networked workspace. And in this networked workspace, we need a new mechanism to deal with one of the greatest dangers humanity has ever faced: radiation and life support systems. The moon has no atmosphere and no magnetic field. This means its surface is constantly bombarded by particles from the sun and high-energy radiation called galactic cosmic rays. The Apollo astronauts spent only a few days in this hazardous environment. But a permanent base has to deal with this radiation for years. Therefore, next-generation habitats are being designed not just as containers, but as multi-layered protective shields. The primary method is to use regolith, the lunar soil, a layer of regolith several meters thick, piled on top of the bases by robots, can naturally absorb a large part of the radiation. The second layer is to place hydrogen-rich materials like water or polyethylene inside the habitat walls. These materials are very effective at slowing down and absorbing cosmic rays. But the real revolution is in closed-loop life support systems. Apollo's systems were open systems that took oxygen from tanks and filtered out carbon dioxide. The new generation of systems takes the technologies tested on the International Space Station even further. These systems can recycle water from astronauts' breath and sweat, recovering up to 98% as drinkable water. They can process urine and solid waste to produce nutrients for growing plants, and the plants, in turn, take in carbon dioxide and produce oxygen through photosynthesis. This is called a bioregenerative life support system, and this is the foundation of the dream of creating a truly self-sufficient ecosystem on the moon, almost completely independent from Earth. In situ resource utilization, sustainable energy, robotic construction, a commercial ecosystem, a comprehensive communication network, and closed-loop life support systems. These 6 technical and institutional mechanisms reveal the fundamental differences that separate today's lunar vision from the Apollo era. It's no longer just about planting a flag and coming back. It's now about building a long-term, sustainable, and economically meaningful permanent presence. Apollo was a sprint, This new era is a marathon. But all these technical details and slow, steady progress plans are only half the story. Because, as history has shown us time and again, great breakthroughs don't just happen through slow and steady progress. Sometimes, an unexpected and shocking moment comes that changes the entire equation, that upends all plans. And in the story of the return to the moon, that moment is now approaching, because all this infrastructure, all this preparation, is actually setting the stage for something much bigger, much more exciting, and much more dangerous. Welcome to the climax of the plot, because now we will see what all these mechanisms make possible when they come together. And it's much more than just building a base. It's something that has the potential to rewrite humanity's role in the solar system. Because that water ice, that rocket fuel, that energy, it's really only opening one door. And behind that door, that water ice, that rocket fuel, that energy, it's really only opening one door. And behind that door is humanity's next giant leap, Mars. But wait, this is not the Mars story, you know. This is not a rosy promise of the future. This is a concrete, engineering-based, and shocking possibility. And now comes the real miracle. Because the infrastructure being built on the moon is not just for staying on the moon. The moon is not a destination. The moon is a launch pad, a gateway to the depths of the solar system. And the first thing to pass through that gate will be humanity's greatest dream. To set foot on another planet. The tempo is increasing. Hold your breath, because now you will witness that epic moment when all that preparation, all that technology comes together. The moment when humanity reaches for Mars, not from Earth but from the moon. Welcome to the climax. It was impossible, but not anymore. The first epic moment. Earth-Moon-Mars orbital mechanics. Going to Mars from Earth is an incredible waste of energy. Because you have to escape Earth's deep gravity well. It's like climbing from the bottom of a valley to the top of a mountain. But going from the moon? This changes the equation. Completely. Because the moon's gravity is only 1/6 that of Earth's. This means a rocket launching from the lunar surface needs far less fuel to reach orbit. The numbers are shocking. The energy required to launch a mission to Mars from the moon is only about 10% of the energy required to launch it from Earth. This means 10 times less fuel. But that's not all. When using hydrogen and oxygen fuel produced on the lunar surface, you don't need to carry a single gram of fuel from Earth. This means the Mars ship itself can be much larger, much more equipped, and much safer. Perhaps it could carry a crew of 20 instead of a crew of 6 for the months-long journey. Perhaps it could take not just a few kilograms of scientific instruments, but a habitat module or a nuclear reactor weighing tons. How is this possible? Because we are escaping the tyranny of gravity. The moon offers us a strategic high ground within the solar system. This, for the first time in history, transforms interplanetary travel from one-off heroic feats into a potentially sustainable logistics operation. The scientific community is divided over this possibility. On one hand, there are those who say it will take decades. On the other, there are those who predict that the first Mars ship launched from the moon could be launched within 10 years of a base being established there. And this changes the entire paradigm. But there was something bigger. The second epic moment. The assembly of the Mars ship. A Mars ship launched from Earth has to fit inside the nose cone of a single rocket. This means a brutal restriction on size and capacity. But what if you assemble the ship in space, piece by piece? This is where lunar orbit comes in. Specifically, the space station planned to orbit the moon, called Gateway. This is a space shipyard. The different parts of the ship, the engine module, the habitat, the cargo bay, can all be launched from Earth or the lunar surface with smaller, cheaper rockets and assembled at this station. This gives us the ability to build the largest spacecraft in history, perhaps 100 meters long, perhaps 1,000 tons in weight. These numbers are UN Beely var Bell, compared to the few-ton weight of Apollo's command module. This ship could rotate on its axis to create artificial gravity during the journey. This would prevent astronauts from suffering muscle and bone atrophy during the months-long trip. This ship could have radiation shielding stronger than ever before. Perhaps it could have walls containing meters of water or other materials. How is this possible? Because we are no longer bound by the limits of a single launch. It's like building a giant castle with Legos. You carry the pieces one by one and then assemble them. This was something scientists had dreamed of for decades. But without an infrastructure on the moon, it was just a science fiction fantasy. Now, it is turning into a concrete engineering plan. Because Gateway is not just a station. It is humanity's port to deep space. And now comes the real shock. The third epic moment. The reduction of travel time and risk. The journey to Mars, with current technology, takes 6 to 9 months at best. During this long period, astronauts are exposed to zero gravity, intense radiation, and psychological challenges. But a much more powerful ship, launched from the moon and assembled in space, could significantly shorten this time. How? By using nuclear thermal or nuclear electric propulsion systems. These systems are much more efficient than chemical rockets and can provide thrust for much longer at a much lower power. This allows the ship to accelerate continuously. A nuclear thermal rocket could reduce the journey to Mars to 3 to 4 months. This is a reduction of half. This means cutting the radiation dose astronauts are exposed to in half. This means cutting the risk of life support system failure in half. But that's not all. This technology gives us more flexible launch windows. To go from Earth to Mars, you have to wait for a narrow launch window that opens every 26 months when the planets are correctly aligned. But with a more powerful propulsion system, the dependence on these windows decreases. Perhaps you could launch a mission every year, or even at any time of the year in an emergency. This was something that should not have been possible. The orbital mechanics of the planets seemed like an insurmountable constraint. But technology is finding a way around this constraint. This transforms humanity from a passenger at the mercy of the planets into an explorer who can chart its own course. And this doesn't just make going to Mars possible, it also makes it reasonable. But wait. The most incredible moment hasn't come yet. The fourth epic moment. Landing on Mars and returning. Mars's atmosphere is a curse that turns landing into hell. It's not dense like Earth's atmosphere, so parachutes and aerodynamic braking alone are not enough. But it's not non-existent either, so landing with rocket engines is also extremely complex. Therefore, the largest thing ever landed on Mars so far was the Perseverance rover, weighing about 1 ton. But a manned mission has to land a vehicle of at least 20 to 40 tons. This makes the landing process, known as the 7 minutes of terror, even more terrifying. But what if your lander comes from the moon? Then, because you are free from the weight restrictions of launching from Earth, you can design a much larger and much more capable landing system. Perhaps you can land not just a lander, but also the habitat to be used on the surface, the power source, and most importantly, the return vehicle, all in one package. But the real revolution lies in the return. To return to Earth, you need to produce fuel again on the surface of Mars. This requires complex chemical processes like the Sabatier reaction. But what if the place you need to return to is not Earth, but your base on the moon? Then you would need far less fuel. In fact, there could be a fully fueled rescue ship waiting for you at the Gateway station in lunar orbit. This completely changes the risk profile of the mission. No longer does everything depend on the success of producing fuel on the surface of Mars. This is a safety net. For the first time in history, in an interplanetary mission, astronauts could have more than one option to return home. This is the pinnacle of what scientists call mission redundancy. And this transforms going to Mars from a suicide mission into a repeatable exploration mission. All these epic moments, all these records, and all these shattered paradigms show one thing. Returning to the moon is not just about the moon. The moon is a key. And this key opens not just one door, but the doors to the entire solar system. Going to Mars from the moon requires 10 times less energy than going from Earth. In lunar orbit, we can build the largest spaceships in history. With nuclear propulsion systems, we can cut the travel time in half. And thanks to the infrastructure on the moon, we can make the trip to and from Mars safer than ever before. This is not a dream. This is a concrete engineering roadmap, likely to be realized in the next 20 to 30 years. But in the midst of all this technical and scientific revolution, the real question still remains. Where is all this capability, all this power taking us? What will humanity become in this new era? Because this is not just about rockets and planets. This is about a philosophical leap. This is about the future of our species. And the answer to that question takes us to the deepest and most thought-provoking layer of our story. Because the meaning of this power is hidden in how we use it, and the consequences of that use. The consequences of that use could be far more shocking than we predict. And therefore, the meaning of this new power is directly related to where it takes us. This brings us to the greatest discovery of the post-Apollo era. It's not a technology, it's an idea. The idea of civilizational expansion. It may sound abstract, but its consequences are concrete, because this idea says that humanity is not a species bound to a single planet, but rather has the potential to spread its existence to multiple worlds. This means, for the first time in history, our survival strategy is moving from a planetary scale to a system scale. This is not just an exploration, this is a revolution, because this idea takes going to the moon and Mars out of being an adventure or a science project. It turns it into our species' long-term insurance policy. And the first clause of this insurance policy is the moon itself, but not in the way we think. The fifth epic moment, the cislunar economy. This means the space between the Earth and the moon becomes a stage for economic activity. This was impossible, because space was always seen as just a cost center, but now it could be a source of revenue. How? The water ice mined on the moon can be converted into rocket fuel. This fuel can be used not only for Mars missions, it can also be used to refuel satellites in Earth's orbit. The lifespan of a communication satellite usually ends when it runs out of fuel, but what if you could refuel it in orbit? You could extend its life by 5 years, 10 years, maybe even 20 years. This means a multi-billion-dollar market. Fuel brought from the moon could be much cheaper than fuel launched from Earth, because it's easier to escape the moon's weak gravity. This is just the beginning. The moon's soil, called regolith, is rich in rare isotopes like helium-3. Helium-3 is a potentially clean and powerful fuel source for future fusion reactors. While this may seem like science fiction today, within the next 50 years, bringing helium-3 from the moon could offer a solution to Earth's energy problems. This could create a trillion-dollar industry. How is this possible? Because commercial space companies already see this market. Under NASA's CLPS program, private companies are already sending small robotic landers to the moon. The cost of these missions is only about 1/10 of a traditional NASA mission. Dozens of companies are competing to search for water on the moon, test mining technologies, and build communication infrastructure. The scientific community was worried that the commercialization of space would sideline science. But now, we see that commercial ambition is making science advance at a pace never seen before. But this economic revolution isn't just for machines, it's for people too. The sixth epic moment, space tourism and long-term habitation. This was something Apollo could not even dream of. Going to the moon was the privilege of only the most elite, most trained astronauts. But now, that door is cracking open. Initiatives like the Dear Moon Project plan to take artists and civilians on a journey around the moon. This is a symbolic step, but behind it lies a massive industry. A hotel to be built in lunar orbit, the first tourist facilities to be built on the surface. These could become a reality in the next 30 to 40 years. But this doesn't have to be just an adventure park for the rich. It also creates the greatest laboratory in history to test the long-term adaptation of the human body to low gravity and the space environment. The first baby born on the moon. This is not just a biological event, this is a philosophical earthquake, because that baby would technically be a human, but also a lunarian. Its physiology, bone density, muscle structure, perhaps its immune system, would be different from a human born on Earth. How is this possible? Because evolution doesn't just happen over thousands of years. If the environmental pressure is strong enough, adaptation can be much faster. This will require us to redefine the term human. Scientists are both excited and terrified by this possibility, because it's like opening Pandora's box. But once this box is opened, it can never be closed again, and this new human will build a new civilization. The seventh and final epic moment, interplanetary civilization. This is the peak where all previous moments converge: bases on the moon, colonies on Mars, mining operations in the asteroid belt, robotic emissaries sent to Jupiter's moons. This is not an empire ruled from a single center. This is a network of loosely connected human settlements spread across the solar system, developing their own cultures, their own economies, perhaps their own political systems. For the first time in history, humanity will not be keeping all its eggs in one basket. An asteroid hitting Earth, an out-of-control pandemic, a nuclear war, such catastrophes will not be able to destroy humanity, because our species will have a backup. This was an idea put forward by Carl Sagan decades ago, but back then, it was just a poet's dream. Now, it is an engineer's plan. How is this possible? Because fuel produced on the moon makes interplanetary travel cheaper. Robotic construction allows for the rapid establishment of new habitats. Closed-loop life support systems create colonies independent of Earth. And commercial competition accelerates this whole process. This is the greatest project in human history. It is a bigger step than the Roman Empire, the Industrial Revolution, or the invention of the Internet, because this changes not just our way of life on Earth, but the definition of life itself. This is the first step of life freeing itself from its home planet and spreading into the vastness of the universe, something Apollo could not even dream of. Going to the moon was the exclusive privilege of the most elite, highly trained astronauts. But now, that door is cracking open. Initiatives like the Dear Moon Project plan to take artists and civilians on a journey around the moon. This is a symbolic step, but behind it lies a massive industry. A hotel to be built in lunar orbit, the first tourist facilities constructed on the surface. These could become reality in the next 30 to 40 years. But this doesn't have to be just an adventure park for the rich. It also creates the greatest laboratory in history to test the long-term adaptation of the human body to low gravity in the space environment. The first baby born on the moon. This is not just a biological event, it is a philosophical earthquake, because that baby will technically be a human, but also a lunarian. Its physiology, bone density, muscle structure, perhaps its immune system will be different from a human born on Earth. How is this possible? Because evolution doesn't just happen over thousands of years. If the environmental pressure is strong enough, adaptation can occur much faster. This will require us to redefine the term human. Scientists are both thrilled and terrified by this possibility, because it's like opening Pandora's box. But once this box is opened, it can never be closed again. And this new human will build a new civilization, the seventh and final epic moment, an interplanetary civilization. This is the culmination where all previous moments converge: bases on the moon, colonies on Mars, mining operations in the asteroid belt, robotic emissaries sent to the moons of Jupiter. This is not an empire ruled from a single center. This is a network of loosely connected human settlements spread across the solar system, developing their own cultures, their own economies, perhaps even their own political systems. For the first time in history, humanity will not have all its eggs in one basket. An asteroid impact on Earth, an out-of-control pandemic, a nuclear war. Such catastrophes will not be able to destroy humanity, because our species will have a backup. This was an idea put forward by Carl Sagan decades ago, but at that time it was just a poet's dream. Now it is an engineer's plan. How is this possible? Because fuel produced on the moon cheapens interplanetary travel. Robotic construction enables the rapid establishment of new habitats. Closed-loop life support systems create colonies independent of Earth. And commercial competition accelerates the entire process. This is the greatest project in human history. A step larger than the Roman Empire, the Industrial Revolution, or the invention of the Internet. Because this changes not just our way of life on Earth, but the very definition of life itself. It is the first step of life breaking free from its birth planet and spreading into the vastness of the universe. The cislunar economy, space tourism, and the birth of an interplanetary civilization. These three epic moments show why Apollo's victory was just a beginning, and why the 50-year silence was actually a period of preparation. In that silence, we improved the technology, we created the economic models, and most importantly, we learned to dream again. But this time, our dreams are not bigger than what the rockets can carry. This time, we are building rockets big enough to carry our dreams. But now, it is time to stop and reflect. In the midst of this dizzying pace, these epic moments and this technological revolution, we must slow down. Because we have not yet asked the most fundamental question. All this power, all this potential, all this expansion, what does it mean for us as individuals, as humanity? Will it make us better people? Or will we just transport our old mistakes, our old wars, our old ambitions onto a new and grander stage? Because the answer to these questions lies not in technology, but in philosophy. And this brings us to the most important, most personal, and most challenging part of our story. Because rockets can take us to the moon, but they cannot let us escape the truth of who we are, and confronting that truth is perhaps a harder journey than going to the moon. And now we ask ourselves that most fundamental question: all this technology, this expansion, these interplanetary dreams. So what is our place in this picture? It is time to stop and think. Because Apollo's legacy is not just rockets and flags. Apollo's true legacy is a mirror, a giant, silent, and ruthless mirror that shows us ourselves, our species, and our place in the universe. And when we look into that mirror, we are faced with a series of deep and unsettling contrasts. Because the human condition exists precisely at the intersection of these opposites. Going to the moon takes us not only outward, but also deeply inward, to the heart of these fundamental contradictions. The first and most overwhelming contrast is the contrast of scale. On one hand, there is a species that can go to the moon, aims for Mars, and dreams of building an interplanetary civilization. With our technology, we pry open the secrets of the universe. We send robots to a world 380,000 kilometers away. We plan manned missions millions of kilometers away in the future. This is an incredible display of power and capability. But, on the other hand, there is the universe itself. In our galaxy, the Milky Way, alone, there are over 200 billion stars. And in the observable universe, it's estimated there are over 2 trillion galaxies like ours. This is a magnitude that pushes the limits of our imagination. How can it be that we feel so capable and powerful on one hand, yet remain so insignificant and small in the face of this mind-boggling vastness of the universe? This is one of the most fundamental paradoxes of being human. The tragic truth is, no matter how far we go, we will always be smaller than a speck of dust to the rest of the universe. Even with our fastest spacecraft, it would take us tens of thousands of years to reach the nearest star system, Proxima Centauri. Reaching the nearest galaxy, Andromeda, would take millions of years. This means we can never physically dominate the entire universe. We can never fully conquer it. We are like children playing on the shore of the cosmic ocean, having found a few pretty pebbles. But the ocean itself stretches before us, infinite and unreachable. This is a cause for melancholy. But there is also a deep beauty hidden in this situation. Because yes, we are physically small, but our minds can transcend this smallness. With our average height of about 1.7 meters and an average lifespan of 80 years, we can understand the history of a 13.8 billion-year-old universe and the structure of a 93 billion-year light-year space. This may be the most miraculous thing in the universe. We may be the universe's way of knowing itself, of understanding itself. We can analyze the light of stars we cannot reach, model the formation of galaxies where we cannot exist. You are a part of this contrast. You too are looking at this massive universe from this tiny planet. Maybe you sometimes feel insignificant, but at the same time, you possess a consciousness that can think about that universe, ask questions about it, and feel awe at its beauty. This makes you not a passive observer of that universe, but an active participant. Your mind is one of the most complex and beautiful structures in the universe, and this brings us to a second and more personal contrast, the contrast of triumph and fragility. On one hand, there is the immense triumph of the moon landing, humanity's greatest technological achievement, the earth-shaking power of the Saturn V rocket. Neil Armstrong's historic step. These moments give us the feeling that we can achieve anything. They make us think that there is no such thing as impossible. They create the illusion that we are in control. But on the other hand, there is that deep fragility within the Apollo program itself. The 3 astronauts who lost their lives in the Apollo 1 fire, the moments when Apollo 13 came face to face with death in the depths of space. In that mission, the explosion of a tiny oxygen tank brought a massive system of millions of parts to the brink of collapse. The astronauts' lives depended on a makeshift carbon dioxide filter, designed by engineers on Earth using only duct tape and cardboard. How can it be that the greatest triumph in human history also contains one of humanity's greatest moments of fragility? This is the most fundamental contradiction about the nature of progress. The tragic truth is, no matter how advanced our technology becomes, there will always be a margin of error, a risk, an unknown. Even the most powerful rockets can explode due to the failure of a tiny seal. Even the most advanced life support systems can fail with an unexpected malfunction. We are always at the mercy of the laws of nature and physics. This shows that we live in an illusion of control. It means we must face the fact that everything can go wrong at any moment. This too is a cause for melancholy. But within this fragility, there is also a unique beauty. Because the real story of Apollo 13 is not a story of failure, but a story of resilience. In that moment of crisis, hundreds of engineers and scientists in Houston came together to achieve the impossible. Using their creativity, their intelligence, and their collaboration, they brought those 3 astronauts back home. This is a moment where technology was defeated, but the human spirit won. This shows that even in the darkest moments, hope, intelligence, and the will to work together can save us. You experience this contrast in your own life. You make plans, you set goals, but life sometimes confronts you with unexpected crises, failures, moments of fragility. In those moments, you may feel weak and out of control, but at the same time, those moments are an opportunity to reveal the resilience within you, your creativity, and the strength of the bonds you have with your loved ones. Apollo 13 reminds us that our greatest strength lies not in metal and electronics, but in our commitment to one another. This commitment brings us to the third and most universal contrast, the contrast of loneliness and togetherness. Think of that famous blue marble photograph of Earth. That photo, taken by the Apollo 17 crew, shows our planet as a lonely and fragile oasis, suspended in the infinite black void of space. When we look at that photo, we feel our cosmic loneliness to our very core. Are there other intelligent life forms like us? Or are we completely alone in this vast universe? This is a question we don't know the answer to and perhaps never will, and this uncertainty creates a deep existential anxiety. The tragic truth is, according to our current knowledge, the universe is silent to us. Among billions of galaxies, we have not found a single piece of concrete evidence for the existence of life other than our own. This means that no matter how big the universe is, it can also be just as empty for us. It brings to mind the possibility that all our dreams, all our art, all our love might be trapped within the thin atmosphere of this tiny planet. This is the greatest loneliness imaginable. But, and here comes that but moment again, because that blue marble photograph doesn't just show us our loneliness, it also shows us the only thing we have, each other. In that photo, there are no borders, no countries, no races, no religions. Just one home, one human family. How can it be that the deepest feeling of loneliness in the universe can also give birth to the deepest feeling of togetherness? Because that photo reminds us how meaningless all our differences are. We are all in the same boat. We share the same fragile planet. We warm ourselves under the same Sunday, and we are all vulnerable to the same cosmic dangers. This is the most fundamental truth that binds us together. It tells us that our greatest responsibility is to protect this planet and each other. You are at the center of this contrast. You too sometimes feel lonely. You may think you are all alone with your own troubles, your own life's struggle. But when you bring that blue marble photo to mind, you remember that 8 billion other people are in the same boat. We are all together in this cosmic ocean, and this togetherness is our greatest strength. Going to the moon showed us not only another world, but also how precious our own world is. Scale, triumph, and loneliness. These three contrasts are the philosophical windows that the journey to the moon opened for us. They remind us of how small and yet how great we are, how fragile and yet how resilient we are, and how alone and yet how together we are. But there are other faces that this mirror shows, because this journey is not just about who we are, but also about our relationship with time. And this, perhaps, brings with it the most jarring confrontation, because the shortness of a human life against the timescale of the universe pushes us toward both a nothingness and a meaning. And the way we deal with this dilemma will determine the maturity of our civilization. And therefore, this confrontation brings us to the fourth and most timeless contrast, the contrast of the moment and eternity. On one hand, there is the mind-boggling 13.8 billion year history of the universe, a vast ocean of time stretching from the Big Bang to the formation of the first stars, from the collision of galaxies to the birth of the Earth. On the other hand, there is our fleeting existence. A human life, on average, is 80 years. The entire written history of humanity is only 5,000 years. Compared to the age of the universe, this is less than the blink of an eye. How can such a temporary and momentary being find meaning in such a permanent and eternal universe? This is the most fundamental tension of existence. The tragic truth is, we are merely temporary guests in this universe. There were billions of years before us, and there will be billions of years after us. The cities we build, the books we write, the civilizations we create may scatter like grains of sand on the cosmic timescale. This creates the feeling that all our efforts may ultimately be in vain. It can push us into a sense of nothingness, because no matter what we do, we cannot stop that massive flow of time. This too is a cause for deep melancholy. But, and that familiar but appears again, because within this momentary existence, something more valuable than eternity itself may be hidden. The moment itself. We are consciousnesses that exist at this particular moment, at this particular point in the universe. We cannot experience eternity, but we can experience the now, and this now contains the entire past of the universe within it. The atoms in our bodies were forged inside stars that exploded billions of years ago. The oxygen we breathe is the product of a billion-year biological evolution. This connects us not just to this moment, but to the entire past of the universe. We are stardust. And this is not just a poetic expression, it is a scientific fact. Therefore, we are not meaningless. We are meaning itself, because we are the moments when the universe remembers its own past, celebrates its own existence. You are at the very center of this contrast. Your life is also a tiny dot on the timeline of the universe. But that dot is unique and unrepeatable. Within that moment, you can love, learn, create, and feel. This is a privilege that eternity does not have. Your existence makes this moment precious. And the existence of billions of people like you creates human history. That short but priceless moment. Going to the moon was one of the brightest celebrations of this moment. And this celebration brings us to the final and most hopeful contrast. The contrast of destruction and creation. The universe is both an incredibly creative and an incredibly destructive place. Stars are born, live, and then die in supernova explosions. These explosions scatter the heavy elements necessary for life into the universe, but at the same time, they destroy everything in their path. Galaxies merge to form larger structures, but in this process they swallow billions of stars and planetary systems. Human history is also a reflection of this dynamic. Wars, pandemics, disasters. Our history is filled with the painful moments of destruction. But, at the same time, after every destruction, we have shown the will to rebuild, to recreate, to do better. How can it be that the greatest creativity of the universe and humanity can be born from the greatest destruction? This is the most fundamental law of progress. The tragic truth is, pain and loss are an inescapable part of existence. Every progress requires a price. The fire in Apollo 1 was a painful lesson that made the space program safer. The crisis in Apollo 13 led to the development of new emergency procedures for future missions. This means that progress is written in blood and tears. It means that every time we take a step forward, We have to face the fact that we are leaving something behind or sacrificing something. This, too, is a cause for melancholy. But within this destruction, the purest form of the human spirit shines, the will to create. Because we are not just a species that survives, we are a species that creates. We build more beautiful cities in place of the destroyed ones. We make art to keep the memory of our lost loved ones alive. We do science to find solutions to the problems we face. This is what separates us from all other species. We are beings who resist entropy, the natural tendency of the universe towards disorder. We are beings who create order in the midst of chaos, meaning in the midst of meaninglessness. You are a part of this creative power. You too face hardships, losses, and destructions in your life. But every morning when you wake up, you have the power to recreate that day, to make a new start, to build a better future. Your creativity is not limited to great works of art or scientific discoveries. A kind word you say to someone, a good deed you do, a small problem you solve. All of these are acts of resistance against the destructive power of the universe. The dream of going to the moon is also such a resistance. It is the most powerful expression of the will to believe in something greater, to create a better future, despite all the problems, all the wars, all the injustices on Earth. Scale, triumph, loneliness, time, and creation. These contrasts are what the journey to the moon has taught us about ourselves. They show us how complex, how contradictory, but also how miraculous it is to be human. Now we know that we are not at the center of the universe, but we can be one of the most interesting parts of it. Now we know that we are not invincible, but we can show incredible resilience even in the most difficult moments. Now we know that we may be alone, but this loneliness can bind us even more tightly to each other. Now we know that we are temporary, but this transience can make every moment even more precious. And now we know that we can both destroy and create, but the power to choose is always ours. The moon mirror has shown us these things, but there is another layer that this mirror reflects. This is a layer that is not just about who we are, but also about who we can be. Because this entire philosophical journey brings us to one final question. What is the spirit of exploration? What? Is it just finding new places, breaking new records? Or is it a deeper, more fundamental human drive? And can this drive take us not only to the moon or Mars, but also to a better version of ourselves? Because the answer to this question will determine the ultimate meaning of all future space adventures. And this invites us to one final deep thought, one final philosophical layer, because to explore. Because to explore is not just an outward movement, and therefore these deep thoughts lead us to another place, a more internal inquiry. Is the spirit of exploration merely about curiosity for the unknown, or is it also a reflection of the search to understand ourselves, our limits, and our potential? Because going to the moon makes us question not only the universe, but also the meaning of being human. This brings us to the final philosophical layer, perhaps the most unsettling one. What do we do with this knowledge? Having all this cosmic perspective, this technological power, and this existential awareness, how does it change us? Or, more importantly, should it change us? This brings us to the first and most fundamental new contrast, the contrast of knowledge and action. On one hand, we have more information than at any other time in human history. The blue marble consciousness brought to us by Apollo showed us how fragile and unique our planet is. For decades, climate scientists have been telling us with numbers, models, and evidence how the balance of this fragile system is being disrupted. Rising sea levels, increasing temperatures, melting glaciers. The numbers are clear, the problem is evident. But, on the other hand, there is a civilization that struggles to act collectively despite this knowledge. As individuals, we worry, we talk, we debate. But, on a global scale, we are slow to make the radical changes needed to protect our planet. How can it be that we possess the most critical information for our survival, yet find it so difficult to act in accordance with this information? This is the greatest tragedy of the modern age. The tragic truth is, there is a huge gap between knowing and doing. Intellectually understanding a problem does not automatically create the political, economic and social will required to solve it. It's like continuing to smoke even though the doctor tells you, you will die if you don't quit smoking. This shows our species' tendency to prefer short-term interests over long-term survival. Instincts. This too is a cause for deep melancholy and disappointment. But, and that magical word but, comes into play again, because this inaction is not the whole story. At the same time, millions of people around the world are taking action to change this course. Young activists, scientists, engineers, artists. They are all trying to turn that blue marble consciousness into an action plan. Renewable energy technologies are being developed. Sustainable living models are being tested. Global awareness campaigns are being organized. This is the story of hope. This is the story of the belief that knowledge will eventually turn into action. You are a part of this contrast. You too know the problems our planet faces. Maybe you feel powerless in the face of this huge problem. Maybe you think, what can I do alone? But every small choice you make, from recycling to saving energy, from conscious consumption to raising your voice on these issues, is a part of that great collective action. If going to the moon showed us how precious our home is, then the responsibility to take care of that home now belongs to all of us. And this responsibility brings us to a second and deeper contrast, the contrast of the individual and the universal. On one hand, each of us is a unique and singular individual. We have our own dreams, our own fears, our own memories, and our own life struggles. We experience the world through our own eyes. Pain, joy, love, loss. We experience them all in our own personal self. This is what makes us who we are. But, on the other hand, as the Apollo missions showed us, we are all fundamentally made of the same material. The atoms in our bodies come from star explosions billions of years ago. Our biology comes from the same evolutionary root, and our most basic emotions, love, fear, hope, curiosity, these are universal. Every human being, no matter where they live on the planet, shares these emotions. How can it be that we can be both so deeply individual and alone, and so radically universal and together? This is one of the greatest mysteries of human consciousness. The tragic truth is, our individuality sometimes separates us from each other. It can cause us to put our own interests, the interests of our own group, before others. This is the dynamic that lies at the root of wars, conflicts, and injustices. It creates the distinction between us and them. And this distinction is our species' greatest weakness. This too is a cause for melancholy. But within this individuality, there is also incredible beauty, because each individual looks at the universe through a different window. Your experiences, your perspective, your creativity, these are unique, and when these differences come together, they form that rich and complex mosaic called humanity. Science progresses through the collaboration of different minds. Art is enriched by the expression of different emotions. Civilization develops through the interaction of different cultures. Therefore, while our universality unites us, our individuality moves us forward. You are a living proof of this contrast. You have your own personal story, but that story is also a part of the common story of all humanity. Your joy resembles someone else's joy. Your pain reflects someone else's pain. When Neil Armstrong, the first man to walk on the moon, said, "That's one small step for a man," he expressed his individuality. And when he said one giant leap for mankind, he expressed our universality. And in that moment, all of humanity was united in that individual experience. These moments of unification bring us to the third and most abstract contrast, the contrast of the search for meaning and unresponsiveness. Humanity, since its existence, has been a species that seeks meaning. Why are we here? What is the purpose of life? What will happen after us? Asking these questions is one of the most fundamental drives that makes us human. Religions, philosophies, science, art, they are all products of the effort to find an answer to these basic questions. Going to the moon is also one of the most magnificent manifestations of this search for meaning. We set out to understand our place in the universe, to find our origins, to discover our destiny. But, on the other hand, there is the universe itself. And the universe responds to us with silence. It does not offer us a purpose. It does not give us a user manual. It just exists, and this existence itself seems completely indifferent to our search for meaning. How can it be that while we search for meaning so passionately, the universe itself can be so stingy in offering us this meaning? This is the deepest existential void. The tragic truth is, perhaps there is no ready-made answer that the universe will give us. Perhaps there is no purpose in life other than the one we impose on it. This may mean that all our searching is in vain, that all our questions will remain unanswered. This can leave us all alone in the middle of an ocean of meaninglessness. This too is a cause for the deepest melancholy. But that but moment appears here, perhaps in its most powerful form, because if the universe does not offer us a meaning, this means we have the freedom to create meaning ourselves. Meaning is not something to be discovered, but something to be built. We create meaning in the bonds we form with our loved ones. We create meaning in the work we do, the works we create, the marks we leave behind. We create meaning when we stand up against injustice, when we help someone else, when we strive for a better world. This is our greatest power. This makes us beings who triumph over the indifference of the universe. You are a creator of meaning. The meaning of your life will not be given to you from the outside. You will build it with your own choices, your own actions, your own values. What gives meaning to your life is perhaps your family, perhaps your work, perhaps your passions, perhaps a small contribution you make to humanity. If going to the moon showed us how meaningless the universe can be, it has also reminded us how limitless our power to create our own meaning is. Knowledge and action, individual and universal, meaning and unresponsiveness. This final layer contains the deepest truths the moon mirror has shown us. They remind us that it is not enough just to have knowledge, but that we also have a responsibility to act. They show us that we are both unique individuals and part of a common humanity, and they teach us that meaning is not something to be found, but something to be created. But this entire inner journey seems to bring us back to where we started, to the outside, to space, to that infinite void. Because if we want to protect and continue this meaning we have created, this civilization we have built, perhaps we have only one option: to go. But is this going just an escape? Or is it a part of the most fundamental definition of being human? And where will this spirit of exploration ultimately take us? Because the answer to this question could reshape not only our future, but also our past. And in the final act of our story, we will face this ultimate question. Because humanity is, by its nature, an exploring species, and therefore this spirit of exploration is more than just a desire to find new places. It is the most fundamental dynamic of our existence. It is an internal engine that constantly pushes us to challenge stagnation, comfort, and the known. And this engine brings us to the final philosophical layer, to the very heart of this entire journey. It is the fact that going to the moon is not just an option, but an inevitable expression of who we are. Because we are a species that looks to the horizon and asks, what's out there? This situation brings us to perhaps the most poignant contrast of our entire journey, the contrast of home and horizon. On one hand, there is this safe, warm and familiar planet we call home. This blue marble that gives us life, protects us, and has witnessed our entire history. This is our sanctuary, the place where our roots are. But on the other hand, there is that irresistible horizon line, the symbol of the unknown, of adventure, of potential, and of the future. The history of humanity is the story of the tension between these two forces. The desire to stay home and be safe on one side, and the drive to go beyond the horizon and discover new worlds on the other. How can it be that we want so deeply to belong to a place, yet so passionately dream of leaving it? This is the most fundamental dilemma of the human spirit. The tragic truth is that these two desires can never be fully satisfied. When we stay at home, we wonder what we are missing beyond the horizon. When we set out for the horizon, we long for the warmth and security of the home we left behind. This is an internal conflict that can never be fully resolved. It always leaves us a little restless, a little incomplete. This too is a cause for melancholy. But this tension itself is also the source of our greatest creativity, because home provides us with stability and resources, while the horizon gives us inspiration and purpose. One is meaningless without the other. If we only stayed at home, we would stagnate and never discover our potential. If we only went towards the horizon, we would become rootless and lose our identity. But when the two come together, that dynamic process called civilization emerges. We use what we learn at home to solve the problems beyond the horizon, and we bring back what we discover on the horizon to make our home a better place. You experience this contrast every day. You have a home, your family, your friends, your familiar surroundings, but you also have a horizon, your dreams, your goals, the things you want to learn, the places you want to go. Your life is the balance you strike between these two. Going to the moon is the extreme point of this balance. It shows us both how far we can get from our home, and it reminds us in the clearest way how precious our home is. This reminder brings us to a next more practical yet equally philosophical contrast, the contrast of dream and reality. On one hand, there are those grand dreams of space exploration, moon bases, Martian cities, journeys to the stars. These dreams inspire us. They encourage us to think bigger, to be bolder. Science fiction is the purest expression of these dreams, offering us a limitless vision of what might be possible. But on the other hand, there is the ruthless reality of engineering, finance, and politics. Rockets explode, budgets are cut, political will changes. The laws of physics place cruel limits on our dreams. Every single part of a rocket requires thousands of hours of testing and calculation. Every second of a mission involves immense risk and cost. How can it be that the human mind can dream such limitless dreams, while the process of realizing these dreams is so difficult, slow, and full of constraints? This is the eternal conflict of creativity and application. The tragic truth is that most of our dreams, at least within our lifetime, will never be fully realized. Interstellar travel is likely still a very distant fantasy. Building a self-sufficient city on Mars is a project that will take decades, perhaps centuries. This can create the feeling that our dreams are crashing against the wall of reality. This can be a cause for disappointment and despair. But there is also a magnificent beauty in this conflict. Because the constraints of reality force us to be smarter, more creative, and more efficient. Engineers design better rockets by pushing the limits of physics. Scientists plan smarter experiments within budget constraints. And politicians try to bring these massive projects to life by reconciling different interests. This shows that the struggle of dreams against reality is itself the engine of progress. The dream sets the goal. Reality shapes the path to that goal. You are constantly facing this contrast. You have dreams, but to reach those dreams, you have to fight against the difficulties, the obstacles, the failures that reality brings. Maybe you fail an exam. Maybe you get rejected from a job interview. Maybe a project doesn't go as you expected. But when you don't give up in those moments, when you try to find a new way, when you produce more creative solutions, you are doing exactly what the engineers of the Apollo program did. You are fighting to turn the dream into reality. And at the end of this battle, at the end of this long and winding journey, how do we feel? All this dizzying information, this cosmic perspective, this philosophical depth, what feeling does it evoke in you? Perhaps on one hand, you feel a sense of nothingness and melancholy in the face of this mind-boggling vastness of the universe and our own smallness. This is very natural, because we are indeed playing a tiny role on this massive stage. But perhaps on the other hand, you feel that deep awe and hope that comes from being able to possess all this knowledge, from being able to peer into these secrets of the universe, from being a part of this great story. This is also very natural, because we are also those miraculous beings through which the universe knows itself, understands itself. Both are true, both are part of being human. Because without sadness, there is no meaning to hope. Without fragility, there is no meaning to strength. Without loneliness, there is no meaning to togetherness. Going to the moon makes us experience this very dual feeling. It simultaneously slaps us in the face with how insignificant we are and how priceless we are. Now we know. Now we know that the reason we left the moon was not a simple failure or indifference. It was the natural outcome of a race that had to be won. Now we know that returning to the moon is not just a repeat. It is a more mature and more sustainable vision, supported by brand new mechanisms like in situ resource utilization, robotic systems, and a commercial ecosystem. Now we know that this journey gives us not only technology, but also deep philosophical lessons about ourselves, about our place in the universe. It reminds us that we are both small and large, both fragile and strong, both alone and together. We are approaching the end of our journey. It's time to put all these pieces together to see the big picture. Because this 50-year story, stretching from Apollo's first step to today's complex future plans, actually revolves around a single fundamental question. And this question illuminates not only our past, but also our future. Because what does humanity's endless dance with the moon ultimately tell us? We saw the story of our journey to the moon and that great 50-year silence. But I didn't tell you that the entire universe was born in less than a trillionth of a second. In that first moment, a point smaller than an atom expanded at an incredible speed to almost the size of an orange. This is cosmic inflation. In our next journey, we will explore this most violent moment of existence. Are you ready?